Now we'll take a look at Flux. Flux is application architecture which can be used to build client-side web application. Now this architecture works by utilizing unidirectional data flow, and it's pretty easy to use without a lot of new code. The basic architecture of a Flux application has got three major parts: dispatcher, stores, and views. Views are something that we have already seen, that is React components. Now when a user interacts with a React view, the view propagates an action through a central dispatcher to the various stores that hold the application's data and business logic, which updates all of the views that are affected. This works especially well with React's declarative programming style, which allows the store to send updates without specifying how to transition views between states. The stores accept updates and reconcile them as appropriate, rather than depending on something external to update its data in a consistent way. Nothing outside the store has any insight into how it manages the data for its domain, helping to keep a clear separation of concerns. Stores have only a single way of getting new data into their self-contained world: the callback they register with the dispatcher. As mentioned earlier, data in a Flux application flows in a single direction, that is, from action to dispatcher, then to store, and then finally to our React component, that is view. A unidirectional data flow is central to the Flux pattern, and the above diagram should be the primary mental model for the Flux programmer. The dispatcher, stores, and views are independent nodes with distinct inputs and outputs. The actions are simple objects containing the new data and an identifying type property. So the dispatcher is the central hub that manages all data flow in a Flux application. It is essentially a registry of callbacks into the stores and has no real intelligence of its own. It is a simple mechanism for distributing the actions to the stores, whereas the stores contain the application state and logic. Their role is somewhat similar to a model in a traditional MVC, but they manage the state of many objects. They do not represent a single record of data like object relationship models do. More than simply managing a collection of ORM style objects, stores manage the application state for a particular domain within the application. A store registers itself with the dispatcher and provides it with a callback. This callback receives the action as a parameter. Within the store's registered callback, a switch statement based on the action's type is used to interpret the action and to provide the proper hooks into the store's internal methods. This allows an action to result in an update to the state of the store via the dispatcher. After the stores are updated, they broadcast an event declaring that their state has changed, so the views may query the new state and update themselves. Coming on to the views. React provides the kind of composable and freely re-renderable views we need for the view layer. Close to the top of the nested view hierarchy, a special kind of view listens for events that are broadcast by the stores that it depends on. We call this a controller view, as it provides the glue code to get the data from the stores and to pass this data down the chain of its descendants. We might have one of these controller views governing any significant section of the page. When it receives the event from the store, it first requests the new data it needs via the store's public getter methods. It then calls its own setState or force update methods, causing its render method and the render method of all its descendants to run. Then we have the actions. The dispatcher exposes a method that allows us to trigger a dispatch to the stores and to include a payload of data which we call an action. The action's creation may be wrapped into a semantic helper method which sends the action to the dispatcher. This action creator method also adds a type to the action so that when the action is interpreted in the store, it can respond appropriately. In upcoming lectures, we'll explore more code examples to better understand Flux.